Alright, so today we're going to be going over 4.7 radical equations. The objective of today's lesson is students will understand how to solve radical equations and inequalities. To start off, we're going to do a more simplistic problem to show you the steps you go to solve these problems. One thing I'd like to note while doing these problems is you might run into roots that aren't squared roots. So if you're trying to solve this in your calculator, if you go to math and then option 5, you can manually enter what root value you want. So to start off, you want to combine any like terms you can. So you want to subtract this negative, or you want to subtract the 8 over here. So it's negative 4 equals x plus the cubed root of x plus 2, sorry. And from there, you want to eliminate the cubed root. So it'd become, you want to cube everything to get rid of the cubed root. Sorry, my handwriting's crooked, it's weird on this. The cubed root and the cube cancel, so it becomes negative 64, which is negative 4 cubed. It's negative because the root was odd. It equals x plus 2. You want to subtract this 2 over here. Negative 66 equals x. Once you solve it, you want to plug it back into the original equation. So then we'll get 4 equals cubed root of negative 66 plus 2 plus 8. This becomes 4 equals cube root of negative 64 plus 8. Cube root of negative 64, as we found out earlier, is negative 4. So negative 4 plus 8 equals 4. So 4 equals 4. You just verified this problem and you are done. Moving on to a more complicated problem now. You will have more steps, but essentially you're going to be doing reverse PEMDAS as before and combining any like terms when possible. So to start, we have the square root of x plus 10 equals 5 minus square root of 3 minus x. Again, you want to isolate, you want to get rid of the radicals, so you want to square root everything, cancel the squares. Or you want to square everything and get rid of the square roots. So this is x, square root of x plus 10 equals 5 square root of 3 minus x. The square and the square root cancel. This becomes x plus 10 equals, and because you have a radical and a number that is not combined with a square root, you cannot just cancel. You have to FOIL that equation, and once you FOIL it, you get 25 minus 5 minus 5 square root 3 minus x minus 5 square root 3 minus x plus 3 minus x. You want to combine all like terms possible on the right side first so you don't lose track of things. So this becomes 28. This becomes negative 10 square root 3 minus x, because essentially that radical isn't a variable that you combine since you have like terms, minus x. Move everything you can to the left side from the right, so this becomes this becomes 2x because you add the x from the right, and this becomes negative 18 because you subtract 28, equals negative 10 square root of 3 minus x. From here you have to get rid of the radical again. It's tedious and repetitive. So this becomes 2x minus 18 to the second equals negative 10. It's doing the thing again. Square root of 3 minus x. So this side you FOIL simply. It'll become 4x squared minus 72x plus 324. With the right side, you can square the negative 10 and the square root of 3 minus x separately, but what will happen is it will become 100 and then times 3 minus x. So you'll now have to distribute the 100 into the 3 minus x, so it'll become 300 minus 100x. Now combine any like terms you can from the right side to the left side, so move everything over. So the 4x remains the same because there are no other x squareds. You add the 100x and get 28x, and you subtract the 300 and get 24. Positive 24. Can I extend the page at all, Mr. Arthur? Mm-hmm. Can I extend the page, or just go to the new one?
The left side with the bar. There's an extended page with the bar.
Okay. You now have 4x squared plus 28x plus 24. From here, you just want to solve for x. And the easiest way to do that is factor out of 4, because all are divisible by 4. So you reduce this equation to x squared plus 7x plus 6, which is much easier to deal with than 4x squared plus 28x plus 24. So whenever doing these problems, see if you can factor out something. From there, you want to factor further into two terms, and what two numbers multiply to negative 6 but add to 7x. So what you'll get is x plus 6 and x plus 1. From here, you solve for zeros. So x plus 6 equals 0. Subtract the 6. X equals negative 6. Or x equals negative 1. But unfortunately, you are not done because you have to verify your answer much like you did in the other problem. So you have x equals negative 1 and negative 6. So you want to plug this into the original equation. And the original equation was x square root of x plus 10 equals 5 minus square root of 3 minus x. So just plug in negative 1, negative 6 for the x. So we'll start off with negative 1. So negative 1 plus 10 equals 5 square root of 3 minus negative 1. Make sure you keep track of that negative, because if you forget it, your problem will turn out wrong because of a stupid arithmetic mistake. So this reduces to square root of 9 equals 5 minus square root of, or 5 times square root of 4. This reduces to 3. This reduces to 5 times 2. Or 5, I'm sorry, this was supposed to be a subtraction sign between. So it's 5 minus 2. 3 equals 3, and your solution is verified because both sides equal each other. Now you have to plug in 6, negative 6. So negative 6 plus 10 equals 5 minus square root of 3 minus negative 6. This is square root of negative 4 equals 5 minus square root of 10. This reduces to 2, or I'm sorry, this is not a negative 4, that's positive 4. This reduces to 2. This is 6. That's 9, sorry. And this reduces to 5 minus 3. 2 equals 2. So you just solved your second problem. So both x equals negative 1 and x equals negative 6 are verified. So your solution is x equals negative 6 or